whatever that is in life, and they end up needing to know it. So, all right. So we'll start here. Is that okay?
Yes, please.
All right. So the first one here, if you're seeing my screen, is a plus b squared. That's a plus b times a plus b. And that's a FOIL. That's a FOIL. So that's a squared plus ab plus ba, which is really ab plus b squared. So that's that first part there. And we'll just simplify that. There's two ab's there. Okay, is that all right?
Yeah, that's good.
And that's everything to this point here. Okay. The next one is we're going to negate whatever we get. A plus b times a minus b, it's a FOIL again. So you get a squared, and we're not dealing with this negative. It's down here. So you get a squared minus ab plus ab minus b squared. And that's FOIL again. And that's in parentheses here. So
And then
see how these cancel?
yeah.
That's difference of squares. That's why it cancels. And you get that in parentheses there, because you're negating all of this stuff.
All right.
So your instructor, whoever this is, they picked a hard one to start. So now we're up to this point right here. Okay, so we're going to negate whatever we get with this thing. So we're going to do it up here because there's just a lot going on. Plus, it didn't format well. This is 2ab minus 2a because you're distributing that a in. Is that okay?
That's okay.
Minus b squared, you're distributing that negative in. Negative with negative plus 2a.
Okay. So then those two a's cancel. And
That's
then we
right.
bring the 2a plus. Oh yeah, I forgot parentheses. I
Yes.
always forget about those.
Yeah, and that's why I make them really big, to make them really emphatic. So now we're gonna distribute this negative in. Distribute this negative in.
Mm-hmm.
And we get some things that are canceling. So these two cancel. All right. The a squareds cancel, and you get 3b squared when you're all done.
All right. We're on to number 3.
Yeah, let me get that chat open here again to get. I see you said number 3. There we go. All right. More of the same. These are really a lot of work. Maybe that's the point here. I don't know.
Yeah, it's a lot. A lot more than I'm used to, at least.
Yeah. So this is one of those where you don't know where to start. So you don't start here. You think, oh well, maybe I start there. Kind of can. So here's what some students would do: is they would distribute this negative to both of these, which is fine. And let's do that. So it's 3x squared minus 7x. So we're distributing that, and then distributing that, plus 2 times 2x minus 1 times 3 minus x.
Oh, all right.
Okay. Now this is the next thing to evaluate because you want to multiply. So you're going to FOIL this, and then you can either choose to multiply by 2 each step or do it at the end. So we'll do it at the end. So it's 6x.
All right.
Minus 2x squared minus 3 plus x.
All right.
Okay, and then now you're just distributing it. So you get 12x minus 4x squared minus 6 plus 2x. And you got this other stuff over here. And then you just combine like terms. So you got this 3x squared, that minus 4x squared.
Yeah.
Combine those. So minus x squared minus 7x 12x and 2x is positive 7x minus 6.
And is that it?
That's it.
All right, good. Now we're on to number 5.
Okay, sniffing that in. All right, number 5 here. So let's see, like I see this thing multiplies all of this stuff inside the brackets, and then you subtract 12 at the end. So really we probably want to take care of whatever this is first.
Yeah.
Okay, so I'm going to bring the x minus 2 down, distribute this negative in. So
negative
that's,
6 minus 2x.
yes. And then nicely, see how this nicely worked out? Those cancel. 2x and minus 2x. Hopefully you see that.
Yeah, I see that.
So you get x minus 2 times negative 6 minus 12. And then you distribute left. So you get minus 6x plus 12 minus 12.
And then you just got your negative 6x, and that's the end of the problem.
And you're done.
Excellent.
15 next.
Yes, that's correct.
Just reading this language in here, it says check. All right. So what I'm seeing here is, okay, a squared minus, but then I got a bracket. So bracket in parentheses means I probably got to, you really probably got to deal with this stuff first.
Oh, all right.
Okay. And like, so some books, some, like, you're used to seeing parentheses, and then some books use brackets next, and then they go to parentheses, and then they can go to brackets again. I don't know what you'll see in this book, but that's how they tend to alternate them.
That's the formula.
So
right.
here we're going to distribute this x into both. So we have a squared minus parentheses, because I'm going to use parentheses in a bracket, xa minus x squared. Okay, and then minus parentheses. Now I'm going to distribute this in, ax minus a squared. You can choose to distribute in negative a if you want, but I wouldn't do it yet. I would do it at the end.
All right. So now we can distribute that negative
Yes.
in the middle. All right.
Minus ax plus a squared.
Squared minus x plus a squared.
So what I see is that these cancel.
Oh, true.
A squared minus x squared plus a squared minus a squared. And then you distribute in this negative. So you get a squared plus x squared minus a squared minus a squared. And then you can choose which ones you cancel, but it becomes x squared minus a squared.
And that's the end of that group.
Yeah. Okay. So you said group 11. Is that right?
Yes,
Group
that's
11.
right.
And we want to look at 1.
Yeah, for
4,
group
5,
11,
and 6.
1, 4, 5, and 6.
Talking about the word problems.
Yeah, not a fan of these.
Okay, now algebra test, 39 more pupils passed than failed. On the next test, 7 who had passed the first test failed. And 1/3 of those who failed on the first test passed the second test. As a result, 31 passed the second test, then failed on it. What was the record of passing and failing on the first test? Now, do you just need the answer here, or are you trying to set this up? What's the goal here? What's the game plan for this?
To just show the work and get the right answer.
Okay. All right. So they there's a test,
Mhm.
and some number of people passed it and then failed it.
Yes.
Pass, fail. Okay. 39 more passed than failed. So this number right here is 39 more than that number there. So x is 39 plus y. Do you see that?
Yeah.
On the next test, 7 who had passed the first test, so that's this group right here, 7 who had passed the first test failed, and 1/3 of those who failed on the first test passed the second test. Okay, so they're saying that 7 of these, this is weird, 7 of these failed. So let's keep this going. So 7 of these failed. 1/3 of those who failed on the first test ended up passing the second test. So that we'll keep this as the pass. So 1/3 of those they passed.
All right.
As a result, 31 more passed the second test than failed it. This is weird. Okay. As a result, 31 more passed the second test than failed on it. 7 who had passed the first test failed, and 1/3 of those who failed on the first test passed the second. As a result, 31 more passed the second test than failed it. See, there's, okay, so 2/3 failed it over here. Hopefully that's okay. And then on this next to 7 who had passed the first test failed. So the rest passed it. So we don't know how many this is, but it's 7 less than it's x minus 7, I guess is one way to do it. Okay. Did anything here not clear? Because I'm just trying to piece together the picture. Okay. So this is one of those, like, I would normally sort of make some pictures, but let me just do this in a different color and see if we can make some heads or tails of this. So we need a number that's divisible by 3 here. So let's just pick like 30. Okay. And then 1/3, so 10 and 20. Do you agree with that?
Yeah.
And so if y is 30, then 7 of those failed. So that's always 7. But then 69 minus 7 is 62. So what are we trying to figure out? As a result, 31 more passed than failed. Okay, so how many passed as a result of this?
Oh, 72.
And how many failed?
27.
27. The difference in those, 72 minus 27, it's not 31, it's 45. It's not too far away, but it's not perfect, right?
Yeah.
So let's pick a smaller number. I'll do it in blue this time, see if we can get it. So let's pick like 21. 1/3 of 21 is 7. 2/3 is 14. 21 plus 39 is 60. That's still 7. 60 minus 7 is 53. So these two numbers together give you 60. These give you 21. So did we get better or worse is the question. What is 60 minus 21?
Oh, 39.
Yes. So we got better,
we
right?
Did it. Yeah.
We got it right there. No. We need 31. I'm sorry.
31.
We need 31. So so this number is still too big.
18.
I think so. So keep in mind, we went 30 to 21, and this number went down by 6.
Okay.
We need to go down by 6 again. So we probably need to go down to 12.
Oh, all right.
So let's go to 12. Let me do it in green. Sorry, let me get that back. Max. Okay, green. All right, so if this number is 12, gotta get all these scratched out now. Now that's always 7. So that means 4 passed, 8 failed. 39 plus 12 is 51, minus 7 is 44. So we have 46 here. I'm sorry, no. I'm sorry. We have a 48 here. Okay.
All right.
And then we have these two numbers, 8, we have 15. Is that right? Oh, we didn't go far enough. So we have 48 minus 15, that gets us to 33. Okay, so it must be 9, because 9's the next one.
Okay.
So what was the rest? So 9. So the correct answer is that y is 9, and then 38 passed and 9 failed, or 48 passed and 9 failed.
Awesome.
Okay, hopefully the next ones are more straightforward.
Yeah. Next one is number 4.
Okay, number 4. This one is more straightforward. Okay. 2 motor buses start at the same time and go in the same direction.
All right.
Okay, so they both start here. I'm sorry, they're 210 miles apart. So this is the distance. The distance here is 210.
Yeah.
Start 1, start 2. It takes the faster 10 hours to overtake the slower. So at some point later, this is later, this is 10 hours to overtake the slower. Okay. Oh no, they're doing this, aren't they? Okay. So it takes the faster 10 hours to overtake the slower. So if they're going this direction, it takes it 10 hours. Okay. But they both take 10 hours to get there. All right, so let's see if we can come up with some equations here. So this is your D equals RT.
Yeah.
So we actually have no idea how far this distance is. This is unknown. So we're going to call that the we got to call distance something like that. So they both. So let's just look at bus 1. So bus 1. Okay, its distance is 210 plus however far this is, which we'll call D. Okay.
All right.
And it has a rate 1, and the time is 10 hours.
Okay.
Follow that? The second bus 2, it's not going 210 because it already started here. It's just going a distance. It has a rate 2, and it's also going 10 hours.
True.
Okay. Is that all right?
Yeah, it's fine.
Now, in the next scenario, we'll do this in blue. In the next scenario, they're going towards each other. So we're going to do that over here. The distance they both go together, the distance together. So distance 1, we don't know what that is, but distance 1 of this first bus is its rate 1 times 2. Bus 2 going this way is its rate times 2. They get there. And this is the key. The total distance, D1 and D2, they have to add up to this 210. So D1 plus D2 has to equal 210. Okay, so this may seem like a lot here, but if you look at these two equations, we can substitute in for D1 2R1 and for D2 2R2 equals 210. Now, this is a technique that a lot of students don't see, but if you divide all these by 2, which you can, you get R1 plus R2 equals 105.
Oh.
Okay.
All right.
Now look over here on the left. On the left here, you can take this and pop it right in there. So you get 210 plus 10R2 equals 10R1. Now, which one do we want? Oh, we want the rate of each. So it doesn't really matter which one we solve here. So we'll just say R2 equals 105 minus R1. This is 210 plus 10. We're going to substitute this in 105 minus R1 equals 10R1. Now we're just solving. 210 plus 1050 minus 10R1 equals 10R1. These two add together to get 1260 equals 20R1. So R1 equals 63 And then R2 is equal to 105 minus 63. So the first problem you asked me to work through, we did kind of a guess and check here. We wrote out some equations to do it.
All right.
And by the way, this is like hard algebra. This is not like
Regular algebra.
introductory stuff. Like, so I don't know what this is for, but they're definitely like picking the most difficult problems here to give you.
On to number 5, with
On to number
how
5.
many quarts of water must be added to 5 gallons of 95% solution of ammonia to make an 80% solution?
Yep. So how many quarts of water must be added to 5 gallons of 95%? Okay, so the idea is you've got water, H2O, and then you've got ammonia here, I guess, and we want like, so imagine there's a pathway here and there's a pathway here, and you're combining them together.
Yeah.
Okay, but all the ammonia is coming in, so you get that. So this is percentage times number plus percentage times number equals percentage times number. It's one of these problems. So you currently have, and the easier one is you have 5 gallons of a 0.95%. So that's where we're starting. We're going to start with 0.95 times 5. Plus, okay, so we're adding water. So water is
It's gonna be like 0.8 times x or something, or what?
no, so that's on the other side here. So it's 0.8 times 5 plus x.
Oh, okay.
I'm struggling here. I don't know why I can't tell you what to put here. So it's not 100%. So we'll just call it x.
Okay.
Let me see if this has a reasonable solution before I proceed, because you're giving me these really difficult ones. These are great for studying, but they're tough to start with. Okay, 0.95 plus. Yeah, what am I missing here? Maybe this is one of those other ones. There's 2 types here. Okay, so you currently have 5 gallons, and you want to add some more in there. Okay.
Okay.
And you need this ratio to be 0.8. So you have 0.95 times 5 plus x, and I think that's what I just wrote. Let me do a quick search here. I'm sorry, wasn't expecting this tonight, so
That's okay.
let me see what's going on here. Oh, you know what?
What?
It's quarts of water. That's why this wasn't working.
Oh.
How many quarts are in a gallon?
4. And that's 4, 8, 12, 16, 20 quarts.
Okay, so maybe what I had was right here, because it's x divided by 4 and x divided by 4. Let me do a quick search. Let me see if that actually changes the answer. It should. Now, why are we dividing by 4? Because we want that in gallons. It shouldn't change the answer though. That's not right. We're adding water there. Oh, I'm sorry. I'm making this too complicated. Okay, we're not adding it to the top. We're just adding it to the bottom.
Oh,
Okay, because it's okay. I'm sorry. So it's let me show you this over here because now I'm understanding. It's a 0.95% of 5 gallons. Okay,
yeah.
water is 0% ammonia, so it's 0 times x equals. You want a 0.80% solution. You have 5 gallons. You add x to it.
Yeah. So this is just 0.95 times 5 equals 0.8 times 5 plus x.
Yeah. Now the problem is the answer is going to be in gallons, and you have to convert it to
Quarts, and you divide by
quarts.
4.
Yes.
All right.
So the answer is, are you allowed to use calculators? I'm assuming you are.
Yeah, probably.
Okay, 0.9375 gallons. So no, you multiply by 4. I'm sorry, not divide.
Was that 0.9375?
Yeah, 9375. But you gotta then you have to multiply by 4
Times 4.
to get gallons. Okay, I'm seeing 6 is the next one.
Yes. Wait, so 0.935 times 4, that's the whole problem?
That's it. Well, that's when you solve for x. I mean, you can use a calculator to get this. It's like a
The
couple.
3.9. So how many quarts of water?
Yeah, so it's 0.9. It's 0.9375 times 4. I think you said 3.9.
Yeah, 3.9. And now
Yeah.
do I divide by?
No, that is it. That's the quarts.
Oh, just 3.9 quarts. All right.
Yeah.
We also got to finish number 6.
Number 6. Okay, let me snip that in here. This is another one of those distance problems. All right, the distance from New York to a Midwestern city is 1,080 miles, and the time taken by the fastest train is 11 hours longer than the time taken by an airplane. So we've got New York to a Midwestern city, and we know the distance here. The distance here is 1,080.
Mhm.
So for the plane, and we're always using D equals RT. For the plane, it's 1,080 equals the rate of the plane, okay, times however much time it takes. For the train, it's still going 1,080. It's the rate of the train, but it takes 11 hours longer. So it's the time plus 11.
Oh, all right.
So you generally choose the smaller one to be T and then add, or I guess you could subtract too. If the train is used for the first third of the journey, so that's 1/3 of 1,080. Okay. So what's 1/3? What's 1/3 of 1,080? We'll figure that out. Okay. So its rate is the rate of the train. I'm sorry. Yeah, rate of train, whatever that is. And we don't know the time, so it's the time of the train.
So it'll be 360 equals RTTT or something.
Yes, exactly. Now this is confusing, but you got to use these subscripts to get through this. So the rest of the trip, which is 720, is the rate of the plane. And then its time is the time of the plane. But here, they tell you the total time. They tell you that TT plus TP is 7 2/3.
All right.
So you have equations here, right? This one isn't as nice and elegant as the previous one. So if we solve this first equation, TT equals 360 over RT. And the second one is TP equals 720 over RP. These two together equals 7 2/3. So it's 360 over RT plus 720 over RP equals 7 2/3.
All right. Wait, is that the whole equation?
No, because we're going to solve these for RP.
Okay.
So like an RT. So this first one, RP is equal to 1080 over T, and RT is equal to 1080 over T plus 11. So these equations go like this first one goes in here. So you have 360 over 1080 over T plus 11 plus 720 over RP, which is 1080 over T, equals 7 2/3. So now each of these actually can simplify nicely. The T plus 11 goes up here. Okay. I don't know if you remember. So it's like this. If you have A over B over C, this equals A times C over B. So basically you bring this to the top. So it's 360 times T plus 11 over 1080 plus 720 times T over 1080 equals 7 2/3. Now I'm going to convert this to an improper fraction. It's 23 over 3. So this one on the left here becomes T plus 11 over 3.
Okay.
This one becomes 2T over 3 equals 23 over 3. Notice the 3's can go away, and you get T plus 11 plus 2T equals 23. 3T equals 12, T equals 4. But that's not what it's asking for. It's asking for the rate of each. So you can't stop here. You'd be like, oh, the rate of each. Okay. The rate of each is up here. So let me just grab these and I'll bring them down. So sorry, no, you can't see that. Oh, no. Sorry, it wasn't sure where I was going to snip that to. So the rate of the plane is 1080 over 4, and the rate of the train is 1080 over 15. So that's 180. No, that's not right. That's 270. And I don't know what that is. It's a lot slower. Yeah, do you have a calculator handy?
I do not, but
10.
I do have one next to me.
Yeah, there you go. 72. There's your answers.
All right. Here.
Group 6 should be pretty straightforward here.
Is it miles per hour for both of them?
Let's go look. I don't remember. Yes, miles per hour.
Awesome. All right. Now we go to group group 6.
Yeah. This book, whatever you're using, was written like a million years ago.
It was written in 1940. That's what our
Yeah.
teacher told us.
Yeah, figured.
Hmm.
All right. So the first question here is a difference of cubes.
So is this like the two? Will it be 2 for first for x cubed or something?
You
Oh,
can,
the difference in cubes. Oh, I remember
so
this.
it's a minus b, a squared plus ab minus b. I'm sorry, yeah, plus b squared. And
Oh,
you have
so
to and you have to know this. It goes with sum of cubes. You got to know this stuff if you're in this class. So your a, this is the hard part though, is your a and your b are what I've put in parentheses. That's your a, that's 2x, and your b is 3y.
all right.
The mistake, sometimes some students make mistakes of not figuring that out. So if your a is 2x and your b is 3y, if you can figure that out, you just map them in here. So this becomes 2x minus 3y, and then it's 2x squared. You have to square the whole thing. Then it's 2x times 3y plus parentheses 3y squared. Now, some students can just write these out as they go. I suggest taking your time, unless there's a reason to do it fast.
Oh, I see what you mean.
This is where you stop.
Oh, that's it.
It says, so in the instructions, it says to
Prime
separate
factors.
prime factors. These are both prime. Prime means you can't factor it anymore.
All right, then we're done with that. So next is number 3.
3. Okay, the very first type of factoring you always do is GCF. So your GCF here is the numbers, 6. So you have 6, 4x squared plus xy minus 3y squared. Now, a little cheat you can do here is you can like ignore the y's because they're just going to come in at the end. Like you're just going to put y in at the end. And that would be like, I would actually teach this way because I think it's complicated otherwise. So here you have choices. You can either use the guess and check approach, or you can multiply the first and the last and do grouping. Which do you prefer?
Grouping.
Okay, so you take 4 and -3. 4 times -3 is -12. And you need two numbers that multiply to -12 but add up to +1. So that's
-4 and wait, no, 4 and -3. All right.
right. So this becomes, and the order matters here. So we're going to say plus 4x minus 3x minus 3. So now you do this grouping. You're like, oh, what do I factor out of those? 4x. So you have x plus 1.
All right. So now what do we do with those y's?
We're going to get to the y's.
All right.
Well, okay, let me throw them in here. Wait, this is actually would be a good place to throw them back in. A good place to ask. Okay, y squared, y and y. Okay, so now what do you factor out of the first one? You still factor out of 4x. So you get x plus y. Is that okay?
Yeah, that's okay.
Yeah. And then you put x plus y over here. So you have to factor out a minus 3y to get to that. So,
right.
so these two always match. Like if you say x plus y, they have to match. Okay, so then it's double factoring. So you end up factoring out, you get 4x minus 3y and then x plus y like that. And then you just sneak the 6 in here. So it becomes 6 parentheses 4x minus 3y, x plus y.
All right. On to number 5.
Okay. Wow. Odd. Um, all right, number 5. Okay, so do you see how there's an a in all of them?
Yes.
I'm going to factor the a out. So it's 2 plus x minus 3x squared.
Okay.
Now, for me, I really wish this was positive because I really like it positive. So I'm going to tell you to factor a negative out. So this is going to become positive. Do you see that? This one on the right?
Yeah, I do.
And then x becomes negative and that becomes negative. Because it's going to be easier to factor if you do it this way. Like you don't want these negative x squareds most of the time. You can have them, but it's best to avoid. Now, because 3 only has 2 factors, you can use the guess and check approach.
So multiply to get -2. All right.
You
That's
could
fine.
multiply, but it's like extra work here because it's always 3x and x. You don't have to guess on that.
All right. What do we do now?
That's it. You're done.
That's
So
it.
what your check is, your check though. See how this is minus 3x
Mhm.
and this is 2x. Do these add to negative 1x?
Um. Wait, say that one more time.
Does negative 3x, that's the outer, and does the
Yeah.
inner 2x, does it add to negative 1x?
Yes, it does.
So you're done.
Oh. All right. On to number 15. That'll be the last part of the factoring.
Okay. All right. So again, kind of it's like, how do we want to do this? Whenever you see 4 terms, you generally want to do some grouping. 4 terms like this, you generally want to see grouping. Problem with these is it's in a bad order, so we're going to reorder it. These both have D in it, and these both have C in it, the first and the last. You can also see that the first and the third have A in it, and the second and the fourth have B in it. So you have to reorder it. And it doesn't really matter to me, but I'm just going to choose this. I'm going to say AC plus 2AD minus 6BD minus 3BC. So I just rearranged the terms. So like, those like that.
All right.
Now these first two, what's common between them?
The first two?
Yeah,
Um.
just the A.
Yeah. Sure.
So this, you immediately write over here. Okay. Now it's in a bad order because see how C is there. So
Mhm.
let me rewrite that. That's why that's why this thing is in this book. It's weird. Okay. What do you put here so that when you multiply in, you get minus 6BD and minus 3BC?
Oh, the negative B.
Negative 3B, because that gets you the negative 6BD and the negative 3BC.
All right.
And then it's double factoring. So these two pair together, A minus 3B, and then these C plus 2D is the same as 2D plus C. So you add
You can
those
just
together.
rearrange them and make them the same.
Yeah, like that.
And is that it?
That is it.
Awesome. Next is physics.
All right. I saw this solving literal equations. Is that what you want to work on?
Yeah, practice solving literal equations. Yeah.
Okay, so
I'll say the numbers for those. I'll
okay.
type them in the chat.
Sounds good.
All right, literal equations 2 through 16 even.
All right. What were you planning to use the second hour for?
For the physics.
For this also?
Yeah.
Is this the physics, the 2 through 16?
Yeah, and then after that, there's a sig figs worksheet that's 12 through 24 even, and 29 through 32 for the next hour.
Okay, great. We'll try that. So solve for P. P equals, little p. Sorry, little p. So the answer here that's like is like, do you know or do you believe that the original can be rewritten like this? Like this P just comes off to the side because then it's really like clear, like, oh, I've got to get rid of this.
Oh yeah, that's true.
So if it's on the bottom, it goes to the top. So it becomes yp. If it's on the top, it goes to the bottom, equals little p. I guess that's big P. We got to be really careful about that.
We have the key on the bottom in case they get confused.
Sure. Number 4. This will be our last one before a break here. Solve for b, little b. So I always tell students the first time this is like either make an arrow or circle it. Make sure you know what you're solving for. So you just have to undo subtraction on both of these. So it's p minus a minus c equals b.
Oh. Is that it?
That's it for that one. They do get harder.
Hmm.
Okay, we're gonna have to stop here just because I do need a break, and we'll pick up here in about 10 minutes. Okay.
Awesome.
All right. Thanks, Jack.
See you in a bit.
shortly. Okay, bye.